Welcome everybody to the WebGL meetup. I'm Tony Parris, the organizer. With me is my co-organizer, Damon Hernandez. Say hi, Damon.
Hi.
Hey. Thank you for coming. How many folks here are first-time WebGL meetup goers? Fair amount of you. Well, thank you for the recruiting boost, Angular meetup group. Tonight we're here to talk about integrating Angular and Three.js. We will get into that later. That's going to be our featured speaker, Josh Staples. But first, let me tell you a little bit about the meetup group itself. We are 820 plus members at this point. We've been around for about 4 years. We've reproduced. We now have a Silicon Valley WebGL meetup group as well that spun out of this because the South Bay people were having a tough time getting up here even when there wasn't Gale Force Winds. So they tend to have one about once a month too. So if you're a South Bay person attending this and interested in WebGL, I encourage you to go look that meetup up as well, or just message us later and we'll give you the info on that. But if you're up here in East Bay, North Bay, San Francisco, this is the place to be to learn about WebGL. I want to thank our hosts, Eventbrite, our people, Denise, and hey, where are you? Thank you so much. For the food and booze, our benefactor, Parris, Khachi, who's also speaking tonight, who had the great idea of Eventbrite hosting. Thanks, man, that was awesome. This is a great space for this. Really delighted. So, a bit about me. I've been doing WebGL development now for 4 years. I have 2 books on WebGL published by O'Reilly. My editor's over there, wave Simon St. Laurent. So thank you very much. The books are great. So if you want to learn about WebGL, small plug, go get my books, and I can get you a discount code. You email me and message me. I'll tell you what. You can get the books on ebooks, half price, and all that. Anyway, without further ado, what we're going to do is we're going to have lightning talks first, and then we're going to have Parris and then Josh speak. Did I forget to thank anybody? Kronos.
Yeah.
So the Kronos Group is our ongoing sponsor. These are the people responsible for making the WebGL standard. So we're all happy coding, we're making our stuff, we're writing our WebGL code. Yeah, Chrome runs it great, Firefox runs it great, oh, Internet Explorer runs it great. Oh, guess what, guys? I don't know if you know this, but this runs it, that's an iPhone, in a big fat red battery case. Basically everything runs it. Kindle Fire, your Kindle, what's it called? The Fire TV. If you want to make a Fire TV app, it runs WebGL. The reason WebGL exists is because of this group called the Kronos Group that makes that standard. They're not the World Wide Web Consortium, but they're kind of friends with them, and they have developed this standard that means we can do game graphics everywhere on every freaking device. We have 3 billion WebGL-enabled devices if you add up all the computers and smartphones and TVs that do this now. This is freaking fantastic. You're writing Halo in JavaScript now. How fucking cool is that, right? So thank you to the Kronos Group, and they always sponsor these events as well. We didn't need them for the beer tonight, but they're always there and near and dear to our hearts. Okay, so without further ado, Weidong, you ready? Where are you?
Yeah.
All right, first speaker is going to be Weidong Yang talking about data visualization and WebGL.
Thanks, Tony. Well, I'm giving a lightning talk, so mostly going to structure around just a demo. And let me see if I can turn the computer around without throw them on the floor. Thank you. So, okay, good. Let's see. A few words about, my name is Weidong Yang, and I'm a director for Kinetech Arts, which is a collaboration of art and technology. We have weekly labs where artists and technology just work together to really explore how the interactive technology can work with dance and visual art. I also have Kinetech, which is a 3D interactive data visualizations, and really we use cutting edge technology like WebGL, Three.js, and use like gesture interactive technology like things with deep motion, with Connect, and see what's possible out there. So what I'm going to present today is a project we did for Box at Boxwork in Moscone Center. It's a visualization of 3D, in 3D, a communication graph. How many people heard about graph before? Oh, quite a few, yes. This is not like a GIF graph or JPEG graph. This is really, a graph is you have many entities and you have connections among different entities. Like to visualize that connectivities. So let me go to my, if I can find my cursor. Here we go. So it's a little bit small, but what you see, there's many dots, and each dot is a person in a company. So but this is all from the real data. Let's see. If I can make, yes. So they collected communication data over the time. And this is one of the healthcare company that use Box products. So you, from people usage, you can figure out who and who has communication, who is connected. And over the time, you build up this graph, and it's very telling about the company's communication structure. It's actually tells more than communication structure. It tells you about the culture, about people relationship inside the company. So we did that for 7 industries, and you can clearly see the different industry has a very different style of communication. So what you see here is in the health industry, and now we have in a fly-through mode. The project is done in Three.js, WebGL, so everything is presented in 3D space, and because of that, you can emulate the camera fly-through movement to get, so it allows you to fly to a person or a connection. So let me show you another example. This one is finance. Let's see how finance look like. So at the Moscone Center, we set up this system. This is on the big TV wall. We use Kinect to track people's movement. And we turn that movement to allow people to literally fly through the data. And it's quite interesting. So the arrangement of all the dots is done by physics simulation. Essentially, you assume each pair of nodes has a repulsion force. Like if there's no connection, if I do not know you, I kind of push away from you. But if we know each other, we kind of pull close to each other. So you do that for every single entity and every pair of entity. And you get this like a self-organized patterns. It's really fascinating. And it tells so much about the organization. So this is joint project between Kinetech Arts, Kinetech, and Box. And with the Kinetech Arts, we always strive for bring art to data visualization. And I'm going to show you a quick example of how it looked like in the when you have dancer dance with it. Oh, I guess I just lost the internet. Did I? Refresh? Good suggestion. Oh, there we go. Let me. So that gives you an example of how we work with the data and the body gesture interactivity. And her hand and the body her hands become black holes that pulls the dots around her. So the dots kind of swing with her. And her gesture, her body creates like a hurricane type of force. And when she moves, those force kind of blows the dots around. Did I say blow? We have a huge wind tonight, so be safe. That's Kinetech Arts dancers, and we use dance and this kind of visualization to kind of experiment how human and data can interact. Especially in the future when 3D visualization become more and more common, and how do we interact with it is going to be a big problem. It's a good challenge. So what's next? Right now, we're expanding this to true 3D display, like using a 3D projector, or even putting in the virtual VR headset like Oculus Rift, and we put a leap motion in front, and then when you put your hands in front, literally you can move the cloud of data around. You can get close to them, you can touch them. So that's an ongoing project we're working on. Another thing we're working on is this is on the web. Naturally, it's distributed. Naturally, it opens up for communication, collective working on the same data set. So we are working on have multiple teams from different cities all access the same data set, all look through the virtual reality VR Oculus Rift. Everybody can touch, can manipulate, can add a dot, can create a new link, and everybody else can see immediately. It's really, really exciting field. Yeah.
What bottlenecks have you encountered and how have you approached their solution?
Good question. Well, we cheat, definitely. Yeah. So with WebGL, it's great technology. It's not possible to do this visualization on the laptop without graphic card. But there's a graphic card limit. We found that the limitation is not really in rendering the entities. With WebGL, we can render up to million entities. You can put a million people out there, no problem. The problem comes with calculating interactivities. Imagine you have 1 million people. Every pair of them has interactivity. Now you have a terror pair of interactivity, and you try to calculate terror like a pair of interactivity every frame. You will see where the bottleneck is. So for us, the bottleneck really is simulating the physics behind such a system. We did a lot of optimizations, or you can say cheating, to let it relax and be able to still obtain like 30 frames per second at least for good vision. Yeah.
So for the box visualization, did you lazy load the names of the nodes, or were they just like?
Those are small data sets. So especially we're not intended to run this as a web app. So it's as a demo app. We can just load everything, let the browser load everything, and then let it start.
So did you run into any limitations of rendering text?
No, not really. We don't have too many things to render. So.
How'd you do the text actually? Was that CSS and
It's a panel like using we render text in 3D objects. Yeah. But,
So if I understand correctly, based on the video you showed, one of your ultimate goals is to connect visualization and data analysis with human motion. Is that correct?
That's it. That's
Okay.
it. So the end goal for me is be able to treat the data as data object. Like this pen, why do I want to use a mouse to move the pen to my hand if I can just grab it? The data, we deal with the data every day. Use a mouse, use a type box, typing the number, drop down box, and we do that every day. We take for granted. But what if you can direct touch? That's going to change the whole thing.
Okay, so following up with the question I wanted to ask, so data analysis is a very knowledge worker domain.
Yeah.
Have you considered how you sort of deal with the issues coming from the limitations of specific human bodies? For example, people with paralysis or arthritis. They would have a personal issue sort of doing the motions required for this visualization analysis, which restricts their knowledge working abilities. Have you given any thought to the limitations there?
To be honest, I haven't. But the interactivity with the gesture interactivity is just first step. And the limitation is not to how we use our hand, use our body in the daily life. And like, for example, Steve Hawkins, and he has severe limitations, but you can, with the interactive technology, you can use different part of body, different kind of input to communicate with the thing. So definitely, I think there's a lot of possibility out there.
one more question?
Yeah, go ahead.
Are you using a Kinect to capture, and how are you, if so, how are you bridging that to Three.js?
Yes, we actually built connection with Leap Motion, with Connect, with the infrared camera. So we actually modularize input, like we have a communication center that kind of transport the data. So the data is a little bit jump. There's a couple of hoops to jump around. First, use OpenSOM control, and then you have to convert it into a WebSocket to stream into the web browser. Well, thanks, Tony.
Thanks for that.
I have a question for you. So what's your business model?
Well,
I'm kidding. Seriously, that was one of the coolest, most beautiful things I've ever seen on a computer screen. But if you do want to talk about business.
Yeah, I do actually. It really depends. It has a long term or short term. In long term, I want to solve a big problem, which is how we work with the data, how we interact with data. How can you make data interactivity just like holding the pen or holding a glass? Short term, that long term goal is probably like 4 to 5 years away, and I still have to make a living. So we're using consulting practice as a way to continuously drive the technology and accumulate the know-how and the technology until the point comes where we have enough that we can really have a revolution in how we work with data. Thanks, Tony.
Thank you again, Weidong. That was phenomenal work. Thank you for being here.
Ready, Daniel? You want setup time?
I think, is this okay? Can you hear me?
Yeah.
Oh. So just put it on.
Okay, next up we have Daniel Ribiero. Daniel's day job is at Square. Daniel is a WebGL enthusiast who's been doing some really crazy coding. I don't even know how to describe what he's about to show you, but that's okay because he's going to do it. So without any other pauses here, you're going to go on the headset. Great.
Yes,
Daniel.
thank you. Thank you, Tony. Let's get started here. Can you get me the link of the
right.
please? Let's see, we are So, hi, I'm Daniel. Thank you, Tony. Thanks for the introduction. I work at Square. If you guys have seen any of these readers, we have quite a few of those around here in San Francisco. So that's the Square, not Square Enix, not to be confused with that one. And let me just get this set up. Cool. So I want to talk to you. The first question I have is, what's the sound of a credit card swipe? Like, does it even make sense? Does that question even make sense? So let me start with the story, the Angular story. More specifically, with one of the creators of AngularJS, Adam Abrams, which is the guy on the right. If you go all the way back to the origins of AngularJS, there he is. And a few months ago, he showed me a very interesting demo. Let me display to you. He took one of these readers, put it in his laptop, opened this very web page, press start, allowed, because I'll go into details why that is. And swiped. Let's see. Just did it all.
There we go.
Yes. So here we are using WebRTC to see the sound. And here it is. So he showed me this very same demo. And I said, wow, this is pretty amazing. This very exercise, this very action happens millions of times every day, and I thought, wow, it feels a little bit like magic. But it looks just like noise. Can maybe we visualize it, like, because this actually is not a really audible sound. Can we maybe see this in more detail and maybe take all that information and put it in a larger space so that we can understand it a little bit better? And this is what I came up with. So this is essentially a fake signal. So if you just want to look at a little bit into it. And this is a visual representation of that signal. It's in a 3D space, you can show a lot more. We can show a lot more details, and we can actually see the topology of that signal becomes an actual terrain topology. So I can actually turn and look a little bit into this signal, how it would look like in a terrain topology. And here we can see, if we pay attention, we can actually see a lot of those details in a much easier way.
This is in frequency domain versus time.
Which way is time?
How many octaves?
That's a great question. Those are all great questions. Thank you.
That's Shannon. Security.
Thanks for bringing it up. So those are all great questions. The first thing is essentially the way this is displayed, we get the time, and the time is spun around in a circular spiral with some distortion, so that we can spread all that information in a broader space. The second part is fractals. We were talking about octaves, and this is where this comes, right? Like, how can we augment that signal and display that information in a much more interesting way? More specifically, it's actually very common approach in 3D graphics to grab a signal and create a fractal out of that signal. And essentially what you do, some people will call, like, you take the hypergeometric sum, which is a fancy way of saying you take the signal, you keep having, you keep doubling the frequency and having the amplitude, and you keep adding it up. You don't need to go all the way to infinity. If you go all the way to infinity, you will have a fractal. For displaying graphics, you usually can stop somewhere. We stop at 4, after which you're adding very little. So we actually, Square has actually produced quite a few different models of readers. Some people have been paying attention. We are coming up with the next version is for reading chip and pins, which it's coming up. It's 2015. The first one was 2010. This one wasn't actually ever released, but this one was. So if we actually plug it in, we can take a look at what it looks like compared to the other one. So if we come here, and we can see it. If you look at it, just from the terrain geometry, you can say, oh, this is very different. And this was the first one. Then we had two years later, we released another one, which you can see here. So it's very, very different. Again, just from the topology, we can see just from looking at the wording you can see. And finally, the first one that I showed here. And this one is our best reader. We can look at all the amount of information that it holds. This is actually what makes this reader a lot more effective. If you ever wonder, like, oh, why in the beginning of Square I had to swipe multiple times? That's the reason. You can actually see the reason. You're sending a lot more data. There's a lot more technology in this one. It's ridiculously exciting. Please.
Doesn't the waveform change with every swipe, depending on how fast you swipe it, how hard you swipe it, how close you are to?
It depends on the credit card. It depends on the reader model. It depends on how it works. It depends on the hardware. It depends on the technology. Yes, it's a great question. It does. Yeah.
Are the credit cards, is that a magnetic signal turned into electrical signal from the credit card? Is that what we're looking at?
Yes.
Okay.
Yes.
And what is the type of encoding? What is the... What? I have no idea.
It's analog
Great
audio.
questions. Amazing
It's
questions.
analog audio, right? And that's what you're getting into the...
Amazing questions. Those things are amazing questions. It's awesome.
So I just took a picture of this. Does that mean I have your credit card number now? If I can figure out how to do it?
That's a very good question which I can answer. This credit card is expired.
Find out.
So yes.
So if you can get this, go ahead. Like it will work on our staging environment.
As I understand it, the newer readers encrypt, and you couldn't really do anything with it. That's true, right?
A very good question. At Square, we are very, very conscious of security, and we work very, very hard to make sure that merchants are not liable for holding your credit card sensitive information, because there's all sorts of PII risk concerns on this, and we take very good care of our merchants. Moving on, to talk a little bit about
Yeah, about 2 minutes.
That's great. I think that's all I need. One of the great inspirations for this was actually CubeSlam, which is a Chrome experiment that Google launched in June last year. It's pretty amazing. They did a lot of things about procedural terrain generation, which is not really what I was looking into, because usually the terrain generation just uses some random purling noise, which kind of distorts and makes the signal not really recognizable. Of course, WebGL, thanks to Newsroom. WebRTC, which is this new standard for real-time communication. CubeSlam uses it for peer-to-peer game playing. I use it to actually read it. And one of the cool things is that I don't actually limit the demo just to credit card swipes. It actually applies to all kinds of signals. So if we can get some, we can actually so here with this, you can actually see some. And this is what that little bit would look like. And it's Shadow of the Colossus. It's from Shadow of the Colossus, which is an amazing 3D indie game with an amazing soundtrack. Thanks to them. And that's it. I'm Daniel. This is my link if you want to contact me.
There's time for a few questions. Let's go.
Okay, so I think I want to summarize, it seems like everyone's questions during the actual talk with one question. How do we as humans read the data that you've generated as terrain?
How we as humans read the data.
Can read it. Like if you could you create sort of like a documentation that if I could study it, I could look at this waveform and go, this is
Yes,
X, Y, Z.
there's actually, if you look at it, there's a lot of information. Like those signals, they contain a lot more information than the string is displaying. This is a very it's summarizing a lot of information. Credit cards are like, they contain quite a lot of information when you look at it. There's on the max structure, there's a lot more information, and the chips that are coming on credit cards, US is one of the last countries in the world to start accepting, to start putting chips. And that contains even more information. The amount of information that comes on a chip it's very advanced technology. I couldn't show it because it's still in release, the reader, but maybe in a few months I'll be able to show it. But yeah, essentially, yes, we do have those docs in general. There's a lot of technology. We do have some proprietary technology to make sure that all of those things, personal identifiable information, is sent from the customer to Square in a safe manner and is stored in a safe manner. Most engineers, the vast majority of engineers, cannot even get that information. So there's a lot of technology that goes behind it.
Time for one more. So, as far as the amount of information that's on a card or one of the pieces of media that's used, are we talking like a document, or are we talking like a song, or are we talking like a movie, as far as how much information is striking? And a chip.
The chip is insane. The chip is way like the process on a chip processing, we could spend like a few days or weeks just talking about that. There's like anti-tampering technology. It's like you have to understand a little bit on how credit cards work, because there is a lot of things that some people will talk, oh, the chip is actually an acquiring bank. So when you start going into that level of detail, there is a lot of information. As it's transmitted, it's a much smaller payload, even the way it is. It's a much smaller payload. But the validation and everything that goes behind the scenes, it becomes much more complicated. We make it super simple. We work really hard to make it super simple. We take the toll on us. And of course, the banks and the whole system takes their toll on us from that jump. But
All right, guys.
Thank you very much,
We want to keep moving. Great job, Daniel. Thank you. Take it away.
So, I'm Parris. Work here at Eventbrite. Oh, hey, how's it going? I'm a software engineer here. I work on the registration and ticketing team. I hear people use Twitter. Sometimes I use it. Was that joke old? Yeah. Anyways, so yeah, we do venue maps. What is a venue map? A venue map is a visualization of a venue. It's representative of the seats and where you can sit. And actually, there's a lot of complexity to it. So you think, oh, it's a limited space, like it's some box, like it's probably less than 100 by 100 feet or something. And then all of a sudden you realize there's 30,000 objects on screen that you need to render, and you want to kill yourself. So, how did we, where did we start? Around a year ago, we started with actually letting people create their own venue maps using a tool kind of like Photoshop, kind of like Keynote or PowerPoint or something. What you do is you say, I have a section. That section has a bunch of rows and it has a bunch of columns. They all represent where people sit. You can also edit this section and delete a bunch of seats and then make them into funny shapes like wedges, or make them curved and do all sorts of interesting things like that. There's an entire other set of people that like to have tables at their event with circular tables, rectangular tables, different number of end seats, so on and so forth. There's also different main attractions at different events. So at some events, it's a stage. At other events, it's a dance floor. And depending on where that is where you want to start selling all of your seats from. So in this view, you can see like there's a seats tab, there's this tab that determines selling order, there's a tab that determines what the price of each seat is, and this is what the organizer sees as they're designing their entire venue. So this entire thing sounds a little tedious, so we created some other tools. We created tools around, you can automatically generate some venue with some capacity, and you can just carry that forward. Or of course, you can start with a blank canvas and work your way up. So this was all great. We won some awards and we were pretty happy about ourselves. We were like, sweet, these interaction designers really like what we did. Awesome. The problem was we knew we had more to do. Those two last slides that I showed you were done in SVG. And of course, in SVG land, you have a cap of how many things you can probably render on screen depending on device. So we hit the cap at around 3,000 seats. So you'd say, 3,000 seats, that covers like lots of things. To give you a perspective of what sort of venues have what amount of seats, AT&T Park, HP Pavilion, Oracle all have around 30,000 plus seats. A larger venue, such as the Speedway, what's that Speedway? Or maybe Fenway? Anyways, they go up to 250,000 seats. So we had some work to do. We had a lot of work to do. So we introduced WebGL and Three.js into our stack, and everything was great. Just kidding. Nothing was great. So in college I had done graphics algorithms and all that stuff, and I knew it was like more work. That's why we started the SVG route and we tried to see how far we could get. We started implementing stuff in Three.js and we're like, sweet, we can do like 6,000 seats now. We've doubled our performance. This is amazing. And it's like, well, that's still shit. Like, you've done nothing. We're trying to get to 250,000. Like, why can't we do this? So the answer is no, sort of. Three.js gives you powers, magical powers, but it doesn't give you everything. But what it does give you is options. And by options, I mean you actually can improve performance as opposed to SVG. You can say, I have control over my destiny and I'm going to render things in this way based on my application, and it's very specific. So I can talk about a million things today about how we did this, but we were talking about text earlier, and if you noticed in one of the previous slides, we have a lot of text in our application. So how do we render that? And what does it mean to render text in WebGL or Three.js specifically? And how can we reuse this code in iOS so we don't have to rewrite this entire rendering engine multiple times? So I'm going to show off some examples. So for text, in this example, it's really simple. This is a Three.js text geometry. And so what's happening here? We have some stats in that right corner. You probably can't read them. It says 0 textures, 1 geometry, 1 program, 5,952 vertices, 1,984 faces, and 1 draw call. So awesome, 1 draw call. I have 60 frames per second. This is great. Yes, but how about if you keep adding more and more text? So let's look at this code real quick. What's happening here is a bunch of setup. I have a camera, a perspective camera. I have a thing that creates text, a simple text geometry. It creates a mesh, it returns that mesh. On resize, yeah, fill up the string, whatever. On render, yeah, whatever, render the freaking scene. At the bottom, this is the interesting bit. We're going to create a text mesh. We're going to add it to the scene and render it. That's all we did. Now, what if we have a lot more text? In this one, we're going to say, let's render 1,000 strings. And with 1,000 strings, you'd think, oh, that's not a big deal. I render 1,000 strings in my browser all day long. Yeah, so it's crazy fast until you hit 541 geometries. At that point, it stops, and you'll get one every few seconds, maybe one every 10 seconds. This means that, and if you look at the stats, it's like 547 geometries, 3 million vertices, 550 draw calls. And so you're like, okay, well, there's this technique I heard about where you can merge a bunch of geometries together and I'll get one draw call. Cool, let me try that. That's what everyone cool does. That's what the internet told me to do. So here we have, I'm not going to start at 300, I'm going to start at 100. So at 100, oh, by the way, if I try to close this, it won't close. Everything's fucked. It's all fucked.
You probably allocated about 300 megabytes of main memory.
Right. Yeah, so it's going to try to free all that out, do a bunch of stuff, and it won't close. So I'm going to start this third example where I actually merge meshes. Let me walk through the code a little bit. Here's the geometry for the scene. I'm going to merge in the text geometry, merge in the matrix for that text geometry, which helps me position it. I'm going to create a mesh based on that geometry, and then I'm going to add that to the scene. So in this example, what happens? So, oh, cool, it rendered really fast. There's a lot less vertices. Yeah, no clapping yet. So I'm gonna bump that up to 200 strings. Still nothing. That's still like nothing. But now I want you to observe the amount of time that it takes to actually show anything on screen. 1, 1000, 2, 1000, 3, 1000, 4, 1000. Takes 4 seconds. I missed a few seconds there. It probably took 5 seconds to render 200 strings. That's mostly the cost of merging everything together. Now if I do 300, 1 1000, 2 1000, 3 1000, 4 1000, 5 1000, 6 1000, 7 1000, 8 1000, 9. It takes 9 seconds to get 300 strings onto the screen. I have 60,000 seats to render. This is not going to work out. So we had to come up with a different strategy. And so what we ended up doing was a technique that we had read about online a little bit. It was a lot more involved. I'm going to call it the text atlas technique. I don't know if there's an actual word for it. But what we end up doing is for every string that we see, we write it to a canvas, and then we take that canvas as a texture, and we take a plane geometry, which has 4 vertices instead of a billion, and we render the text on top of that. And this works great. This is amazing. Does anyone know what the screen is, by the way? Do you know? Yeah. Yep. So in Chrome, you can install this GL debugger. It'll tell you the state of everything at the current moment, and then it'll tell you about all your textures you have loaded up. It works great. So this is the view of the text atlas that we have created.
Are you saying you made a sprite that counts up to 30,000?
No. Yeah, it's just a sprite sheet. It doesn't count. It counts all the way up to. It has unique versions of every string that we create. So if you use the number, if you have the number 17 a million times, it creates one number on the sprite sheet. Yeah. So what does this mean? How does this work? Is it any better? And the answer is it's way better. And now we get a billion freaking strings on the screen, and it works great. Woo! So up in this right-hand corner, it reads, the textures are all messed up because of something, so we're going to ignore textures. Geometries, there's 3,473 geometries on screen, and it represents way more data. There's 6 programs running, 2 faces, 2 whole faces, and 1 draw call. So we're doing great, and this is running at a smooth 60 frames per second. So how do we do this? So you now know that we write things to this sprite sheet, but there's other problems here. Text, how do you center text? How do you make it all be aligned? all of a sudden you need to figure out not only what the height of each symbol is, you need to figure out the width of your string. You can't separate out all of your symbols because then all your font is monospaced. So you actually do have to take full strings. But here what we did to figure out the height. We were able to figure out the width using a canvas trick. You can create a string in Canvas and say what's the width, but you can't say what the height is. You also can't tell what the baseline is. So what we had to do was count pixels to figure out where the height of all this stuff is. And then to figure out the baseline, we said, what's the lowest point in the string? Then what's the next lowest point in the next character? And then from that, we figured out where the baseline was, we figured out where the height was, and then we started writing text all across this atlas. And then we did this once per font, and we got a ratio for this font. And
This is where you mentioned Google and Firefox and say, give us the font info in the browser already, right?
Yeah.
You wouldn't have to do that.
Totally. But we ended up doing it, and it worked. So, yeah. So caveats. We learned a few other things here. We learned that each platform has a different max texture size. What this means is the amount of data you can hold in that spreadsheet is variable dependent on which graphics card you have, dependent on which driver you have. So if you run out of space in that map, then you have to create a new one, and that is different for each graphics card. But you can get that information easily. Another thing we wanted to do was pack the strings up really well, but in our use case, we didn't quite know what strings we had until we rendered them. So if you know what you have up front, you can render them, but if you in a smart way and minimize the amount of textures. But if you don't, you're screwed, and you have to just like write them in the most non-efficient way possible. And lastly, around pixel density and anti-aliasing. Obviously, in Retina, this could look shittier, but what we got is a way to. So we basically super sample the text, and then sometimes we anti-alias it, and then sometimes we use a combination of both, but it doesn't always work. Both of them don't work the best in both situations. You can't just turn both of those things on. Oh, and if you switch between Retina in this example, between Retina and normal, everything gets bigger or smaller, and it's pretty funny. Yeah, so that's all I have on text. If anyone has any other ideas to deal with this, let me know. That would be amazing. But moving on to iOS. Yeah, this is a sharp right turn. So we got Three.js running on iOS, and the way we did it was not through WK WebView. It wasn't through Cocoon. We used another library called Ejecta. In this previous slide, we were getting with around 30,000 or 50,000 objects on screen, maybe 50 frames per second. So Ejecta is pretty blazing fast, but it depends, and I'll get to the depends part in a bit. So how Ejecta works is these guys are doing some awesome open source stuff. They wrote a API for basically every browser API, but they didn't implement a browser. So they said, so in this example, they have a WebSocket. They wrote the spec for WebSockets in Objective-C, and they let you access it via JavaScript. And they're running the JavaScript via Apple's JIT compiler, not JIT compiler, but Apple's JavaScript core. So you're getting nearly native performance. There's some kind of crap parts. Oh, cool, this thing crashed. Amazing. That was the one with lots of strings and not merged. So yeah, so this thing works great. So what they did was they took all the WebGL calls, ported them over to OpenGL ES calls, and that's how we get access to pretty blazing fast stuff. So the pros, you can actually embed it into your application, whereas you can't do that with Cocoon, and I'll talk about Cocoon in a second. It's free and open source, there's no browser, and if you don't have iOS 8, you can still use it, unlike WK WebView. On the negative side, if your application is JS heavy, as opposed to GPU heavy, it's going to be slower than a WK WebView potentially. And obviously, like any other iOS library, there's some potential for deprecation, and then you have to scramble to either support that library yourself or something else. or move away or like try to do something else. But this thing worked out great for us. We were getting like 50 frames per second, like I said, and I can show a demo in a second, actually. I'll do that.
We have about 5 minutes, Parris.
Okay.
Show the demo. Some Q&A.
Cool. So WK WebView, still, it's still a little heavyweight. You could use it. I don't think the performance on the GPU side is as fast. Cocoon, you can't embed. You have to just give them your code, and then they spit out something at the end of the day. And Scripting, yes, but then you need to learn C++ and do all that stuff. Whatever. It's cool. Yeah, sure. Use them Scripting. Demo. Well, maybe. Yeah, I'll demo.
I wasn't prepared for this one.
While you're firing that up, did you try Crosswalk? I think it runs on iOS. It runs on Android. Try it on iOS. It's got a good fast WebGL.
Oh, cool. Alright. I'll hit play. This is going to run in an iPad. It's a little slower on in the emulator actually than in real life. We were getting that 50 frames per second on an iPod Touch, like an older iPod Touch. That pop-in is like a level of detail thing, so we hide away a bunch of stuff so we can show more seats. Yeah, cool. And other things. So what else happened? We used some artree stuff for interaction because now the geometries are merged, and that sucks to pull apart. Sucks to try to figure out. You actually have to manually figure out where you're clicking. Some quad tree kind of magic. We tried to create a Raphael.js facade to layer on top so we can backport to our seat designer tool that I mentioned earlier. It's kind of working, not quite. And we wrote most of this stuff in Marionette. So, sorry Angular guys, I'm using Marionette. So yeah, stay tuned. Thanks. Any questions? We're hiring. Yeah.
Time for the field. Let's go.
Yeah.
For the text, for rendering the text in an earlier part of the presentation, you touched briefly on baseline, but I've been running into a problem lately where with individual characters it's tough to tell the difference between, say, like a Q, where the part of the letter goes down below baseline, and the ones that go above, and how do you align those to each other?
Yeah, it's
yelling the whole time.
So the question was, what happens when you have some letters that are kind of off baseline?
Yeah.
And the answer is, that sucks. We use a set of fonts that are very predictable. So each font is going to do things slightly differently. You might need to account for it manually. You might need to say, I'm giving you a different. So if you notice in that slide, we had a bunch of letters that we took as samples. You could avoid the letter Q and take a different sample and say, that's my baseline. And I think we have one font that we kind of ignore one of the important characters, so we ended up doing that. Hey.
Do you think about making a glyph graph instead of a string, a glyph atlas instead of a string atlas?
I haven't actually heard of that technique. The question was, have we considered using a glyph atlas instead of a text atlas? Is a glyph atlas more like each individual character?
Yeah, each individual character, and then you have to sometimes be able to turn
Yeah, so we didn't want our text to be monospace, and we turning all sorts of things. Yeah, we were like, let's just dump the entire string in there, it's fine. That was the only reason.
So with the text, it seems like it's a very difficult problem. I mean, you're essentially reinventing something that the browser does already do very, very well in document land in GL. Do you think it's ultimately a tractable problem to sort of recreate the richness of that document in GL? Or?
I couldn't think of a way, like this thing doesn't even support multi-line text. How do you do text wrapping when you have no, like, you have no bounds on your thing. So even if you have bounds and you want to start breaking things, where's the end of a word? Where do you break that? So I think there's like a million other problems there to also solve. I don't know that you can, unless you have a lot of time, like a month to devote to this, just the text problem, you're probably not going to get multi-line, you're probably not going to get a document. That's what I would say. Anyone else? Yeah.
Did you try CSS 3D at all?
No, not at all. We should talk.
I don't think you're going to get thousands of elements moving around with CSS, though, right?
Yeah, maybe not.
If you try it, I don't think you're going to get 60,000 on the screen.
So now I see why you went up to 17 because of the kerning issue in your sprite.
Right.
But you're sampling the heights of the baseline and the width and all that stuff multiple times, like as you zoom in and zoom out.
No.
So you do it once, right?
We do it
You
once.
just have it in a lookup table then that's related to this. You don't have to have
Right.
hard code lookup table.
Yeah. So we cache the font once, and then we create a ratio for that font. So the first time we see that font in any way, we generate the memoized version of the text metrics, and then we use that from then on out. Yep.
Did you guys ever like try a solution where you just layer like a canvas like directly over like the WebGL? Okay.
We were thinking about that, and then I was like, whatever, let's just do it this way. Like, at some point, you're like, fuck all the options. Let's just do it this way. I don't know, do it some way. And yeah, it seemed to work out. That's where we landed. Cool. Thanks.
Parris.
I got a question for you. Are you going to open source that code?
We're thinking about it.
That would be really great. In case you don't, I would say look around. Isaac Cohen, who works at Leap, I think he's on a sabbatical now. He's done a lot of great WebGL visualization, and he has a little text widgety thing where he solves some of the same problems. I don't know if you looked at that or not. And that's open source, and that's on GitHub somewhere. It could be BO is the guy's handle. Just if you care about that, message us on the meetup group. But we sure hope you open source that stuff too. Wow, that's incredible. And funny thing is I solved exactly this problem, not nearly for that scale. And the reason I had to solve it was I loaded about between 500 and 600 pieces of text as polygons. And it was right around there, it crapped out. That's pretty funny. And I found Kabibio's library because I had to deal with exactly the same problem about 2 months ago. So it's funny. Great job, Parris. All right, I know everyone's getting a little, there's booze going on, we're getting a little sleepy and tired, and there's a lot of tech talk going on here. So 5-minute bio break. Don't get too spread out here because we still got Josh and we want to hear him, right? So take a quick bio break, get some more food if you want. Yeah, still food over there. But come back here in exactly 4 minutes and 49 seconds. All right. Now, every once in a while you meet an engineer who loves to code. Like when you talk to them, their eyes light up. They get all excited about this abstract stuff. Like how to the object model they're going to use that's going to connect up to the pixels they're going to put on the screen. And they love it so much that they maybe even invent something that their boss doesn't want them to do, like visualizing shipping containers. Over in Oakland where it looks like those Star Wars Death Walker things and it's all the shipping containers? This dude Josh built a visualization of that a year and a half ago and blew my mind, not just because he visualized something really amazing using WebGL, but he got really excited about how he did it, how he architected it. And since then Josh has moved on in his job, but he is still kind of carrying the same torch, which is how to design 3D applications the way engineers want them to be designed for all the right reasons. And so Josh is here to talk to us today about how you can bring Angular.js, which many of us are using, together with Three. Take it away, Josh.
Thank you, Tony. So, I'm curious, anybody know the band One Direction? I'm thinking about trying out. We've got the headset, it works great. So, as Tony mentioned, about a year ago, actually, I did a presentation when I was working for Navis about sort of shipping terminal visualization. And the funny thing is, on that night, there was actually a Salesforce conference, and Gale wins, which kind of screwed up the entire attendance of that presentation. But it still went on great, so it was fun. Now I'm working at a different company. So before we get started, I sort of use Twitter too. At Cubicle Downs is my Twitter handle. I made that joke last night presenting in Mountain View, and it did not go over so well, I have to admit. But whatever. I also have a blog at tempted.com, so like Tempt 3D, very clever. All these slides will be up online, which is sort of the point of this pause. Additionally, all my code's up, right? It's live, you can check it out, and we'll get into why that's important in a little bit. So who am I? I am a software engineer who works for a sort of stealth mode startup in Berkeley called NapOfEarth. NapOfEarth is creating this WebGL web-based product that allows you to more or less explore music visually, right? So you're thinking about the visual relationships between music, sort of the different genres, the different artists. There's lots of stuff there. We're currently private beta. If you guys want to join up, there's a hashtag in the top right called #meetup. So if you go to napofearth.com and then use that hashtag, I'll get you into the next list of invites. I guarantee you, if you like music, you're gonna dig this app, right? I'm convinced. I'm like a member and the president of Hair Club of Minna at this point. I'm just selling it everywhere. I'm not actually the president, but just a peon, but whatever. That's the point. So today, what are we going to talk about? We're going to talk about a couple patterns. I spent the last 2 years learning Angular, and I've been working with Three.js and Maya and 3D for years before that. So that's going to be the first thing we're going to talk about. Subsequently, we're going to talk about controller adds and prototypal Angular components. This is sort of like turning Angular work into prototypal work. It's awesome. I love it. It's not closure. So, there you go. Lastly, we're going to talk about grunt and closure compilation approaches. This is sort of like turn your 3D app, your web app, into sort of a productized app ready for the real world. All right, so why? Why am I doing this? So I've spent the last 2 years pulling my hair out, looking at Stack Overflow, Googling everything under the sun. I've subsequently watched AngularJS.org sort of like get rid of their entire commenting system because so many of the comments and solutions that were posted on the site were outdated, right? It's an incredible framework, but it is moving fast. So now I've got these two approaches that are very high productive and sort of, I would honestly say, a low barrier of entry. Once you sort of wrap your head around the basics of Angular, it really makes this kind of integration very easy. I also wanted to point out that a lot of us here might be web devs, but the sort of gap between being a 3D application developer and a web developer is closing very, very shortly. There's no reason why you can't actually be both a web developer and a 3D web developer in this day and age. I also want to demonstrate a way to isolate the Three.js sort of logic, the bizarre that is Three.js, the craziness that is Three.js from Angular sort of code, UI, UX code. So if you sort of think of it, Angular is sort of the framework that encapsulates everything. It is the cathedral of programming languages, right? And Three.js is this just like sort of concentrated bunch of craziness that's happening in the WebGL canvas that you can watch. All right, so I don't really have to tell most of you this, but three what, right? Three.js. Everybody knows Three.js. If you're here, you know Three.js, you're probably using it. Something like 80% of technology on the internet right now of 3D technology is using Three.js. It's an incredible library. If you don't have really high, lofty gains, it'll probably work for you. But until you get to that point, don't worry about it. So Angular who? This is from Google Trends just the other week. So it's like the last, 9 months of Angular on the web compared to other JavaScript frameworks. I've tried a couple other frameworks too, including Backbone, actually only Backbone. But I can honestly say, Angular, when I started learning it, like compared to like jQuery Soup, my productivity just exploded. It's serious. Like it facilitates how programmers think, right? So if you grab onto it and sort of make it happen, it will honestly make you a more productive programmer, and it will make your product better. It's a really, really incredible framework. So that being said, before I get all wordy and stuff, let's actually take a look at what I'm talking about. So for this project, I created a very, very simple, essentially 3D model viewer. But with this model viewer, you can do a few things. You can load a bunch of different sample models. That's a lady. She's actually oriented the wrong way. Sorry about that. GLTF models from Cronus. Thank you, Cronus. You can sort of interact with the scales. You can scale them up, rotate them in every direction. Different ways. Ah, so crazy. You notice the light there too. So my 3D scene has a light. Oh wow. Yeah. You have a bunch of different stuff. You also have what you call a recent. So I'm using the sort of local storage. So whenever you plop in a URL, if you wanted to load any JSON file, any OBJ-MTL, let's load a guy without a texture. There you go. He doesn't have a texture now. If you wanted to load anything, it essentially store those URLs in local storage so you can leverage them later. So think about this as like a long-term sort of model viewer if you want to plop in a URL in any of these places, right? Again, local storage, toolbar. I have this sort of like quick windowing system, pretty basic, about page, file loader, toolbar. You get the idea. So it's pretty basic, but well, what I've done here is I've sort of used the basic patterns I've learned that really work with Three.js and really work with Angular to sort of provide you guys, the community, a way to sort of move forward with leveraging both Angular and Three.js in the same environment. All right, so we'll come back to that. All right, so let's talk about how I made it. I'm not going to get into too deep of Angular work, but all the code, again, is up, available. It's very commented, so you can certainly take a look. But essentially, when you come to the site the first time, what you're going to do is you're going to be directed to either chrome.html or something else, right? I didn't have enough time to make this work in Firefox and IE and Safari. So I just really made it work for Chrome. If you come to the site on Chrome, the ng router is going to route you directly to a template called chrome.html. Top left, right? It's called a directive include, where essentially it says this is directive, and we're going to include this file if you are leveraging this directive. The directive include includes a couple other directives as well. File loader, which is sort of the front and center interface that you actually see. Additionally, there's the toolbar in the bottom right and the toolbar in the left. The toolbar on the left essentially interfaces with the 3D environment. You can scale, translate, rotate, all that other stuff, right? You notice also there are two controllers. Angular sort of allows you to create controllers inside the DOM. And the controller is essentially attached to elements inside the DOM. So for example, the input sliders in the bottom left, as you translate those input sliders, there's a command called ng drag or ng release inside of Angular. So as you drag them, they're actually communicating information back into the 3D environment. We'll get into that in a second. You notice that there are two controllers. There's app controller, which is sort of like the parent controller. It facilitates all the windowing system. It facilitates the toolbar in the bottom left, and everything else inside the window. When you initially load the app controller also loads the 3D environment. We'll talk about how that happens in a second. Additionally, the file loader controller, so whenever you paste a URL, something has to communicate that information into the 3D environment. And the file loader controller does that for us. So let's talk about dependency injection. One of the coolest things about Angular is this feature called dependency injection. So if I create this Angular component and I want to use it in other Angular components, I essentially inject it into additional components, sort of like when you pass a parameter into a constructor, right? Sort of like in the very beginning, you just inject it and then you can use it from there. In this case, you actually see that there's a factory viewer. The factory viewer is the 3D environment. It's sort of like this little square there that's the orange outline. The factory viewer is the Three.js scene that you're going to interact with. Notice that factory viewer is injected into a few other components too. We have a directive select directly above it, the file loader controller, and the app controller. One thing you might notice is that the message bus is the only Angular component that's injected into the factory viewer. This is important. So if something happens in our 3D scene, we need to let the rest of the app know about this. And so what we'll do is we'll essentially trigger something on the message bus. The message bus will broadcast that change and that message payload from root scope. So essentially all these sub-controllers, everything scoped off of root scope in Angular will subsequently be able to grab onto that message and say, oh, something's happened, we need to react. So you can sort of think of this as like if I'm clicking on the canvas, essentially I'm trying to select something, right? Well, that selection has to go into the 3D scene, has to intersect with some 3D element, and then that intersection has to be broadcast back to the UI UX layer. So let's drop down into the viewer factory a little bit. So this is sort of the internals of our viewer factory interface. The viewer factory in Angular version 1 is essentially a closure. So you have this entire internal state, and then you return these functions that's sort of like your exposed API. So you notice in the viewer factory we have something called a init. Init calls home equals viewer scene, right? So this home equals viewer scene creates our entire 3D environment. This is what's sort of initiating the 3.js scene. This is what's initiating orbit controls. This is what's setting up the scene, everything out. It's one line, and it's what I call a superclass. So, and we'll talk about that in a second. Additionally, if you're 3.js guys, you also notice there's an animate and render function there too. This is what creates your render loop. So if you're having a 3D environment, this render loop just starts to spin, right? 60 frames a second, request animation frames. Crazy, it's great. Additionally, we have additional functions there. It's like make selection, a bunch of load functions, and some transformation functions. You notice on the right side, I have sort of listed out the Angular components that leverage those functions. So the init, then the toolbar functions, additionally load functions on the bottom. So whenever one of those external components has to do something in the 3D scene, they're calling those exposed components. That's sort of how we sort of bridge the gap between the UI UX layer and the 3D scene. On the bottom, you notice one function called translate X, Y, Z, right? There's some annotations on the top. Notice param, number X, right? So those annotations are important. We'll get to them a little later. But primarily what they're guaranteeing with a particular compilation process is that any code that calls this translate XYZ in the entire framework will call it with numbers. If you were to pass translate or to sort of set a position in Three.js with something that's not a number, your model is going to disappear, right? If you try and pass a string of 12 into, or 42 rather, into a position set, your model is going to be like, oh, that's not a number. It's going to bail, and your model is going to disappear, right? So annotations sort of allow us to, and it's part of the compilation process, is to allow us to guarantee that we're actually getting numbers and not strings or booleans or anything else when we're passing into those functions. So it's a very, very useful feature. So the viewer scene architecture. So viewer factory is a singleton. So wherever we inject it, it's injected only once, right? So we're gonna have one state, everything else. You sort of see the init and the animate functions right there, give you a general idea. Part of the init, we also sort of create the superclass called viewer.scene. This is a class where, as part of the constructor, I sort of assigned a bunch of Three.js functions. So Three.js scenes is sort of assigned to the viewer scene. Orbit controls, this allows us to move around the scene, zoom in and out, and everything else. We have a few others too, like setup, that sort of sets up the mesh, it sets up the lights, it sets up the grid, the access handlers, everything else. It's really, really works. Additionally, the last one is called the Wrangler. So you might see that in other codes I have. The Wrangler is essentially taking the 3D objects that we have, sort of massaging them, loading them, everything else. It literally wrangles the 3D elements. It's not kind of corny, I don't know, whatever. All right, so let's talk about use case. So if I click on the canvas element, and I'm like, where am I clicking? It's like, am I intersecting with something? You notice there's a select directive right here. Yeah, oh, the mouse shows up, nice. So the select directive shows up. If I click anywhere on that canvas element, which is the full screen size, essentially that directive is taking those XY coordinates of my selection and saying, I was like, what are they? It's like, at that point, I convert those XY coordinates in what you call NDC coordinates, non-device specific coordinates. So it's sort of like, you can think of it as like normalized values. -1 to 1 for your horizontal axis and -1 to 1 for your vertical axis. This means regardless of the machine you're using them on, you can use these coordinates. So you notice at the very bottom of this select element, the viewer factory is injected into the select element. So at this point, I can call viewer factory.makeSelection. That passes those XY coordinates, those normalized XY coordinates, into my viewer factory. The viewer factory creates a ray, projects that ray out into the 3D environment, and subsequently sees if it intersects with anything. If it does intersect with anything, it subsequently triggers a message using the message bus back up to the root scope. The root scope then tells whatever's listening, and this is the third part right here, it's like whatever listening, if you're interested in what I'm intersecting with, if you're interested in the name I'm working with, anything else, it'll subsequently do whatever information you have to do. It's sort of a loosey-goosey a little bit, but. So, that's sort of like the first approach, right? Lots of code. I know, this is a very technical meetup. Intended to be this way, but we're gonna move forward a little bit. So we're gonna try this again, just a different way. So I have a question. Does anybody know what the most profitable movie is in Hollywood?
Avatar.
No. Any other ideas? Nope, nope, nope. All right, here we go. It's called The Sequel. This is actually a study done in the 80s by Hollywood. Like, if we want to maximize our profit for our shareholders, what do we do? So we make a sequel. You already have an established base. You're going to spend, half the amount to do the same movie and make a lot of money. So that's more or less what I've done too, actually, I have to admit. So the sequel, however, stars a couple other features. Controller as controller. We'll talk about what that is. Annotations as situation normal. Fucked up. And also we're going to talk about prototyping all the things. Great. Awesome. So the anticlimactic reveal. Here's the second version. It's an entirely different approach, coding basis, but it's the same thing. And I sort of apologize for this, but I really don't, because sort of my intention is to demonstrate the same product with multiple approaches, right? So it's the same exact thing. Partials exactly as similar, but the entire plumbing is completely different. And we'll go into why. Right, controller as. So in Angular, you have these controllers sort of loaded into your DOM. In previous Angular components, essentially you could have like one controller in there, and maybe you have multiple window controllers. And let's say you click on a window, and maybe you've moved around your HTML, and all of a sudden your function called, hide window is essentially attached to the wrong scope. So this newer Angular version allows you to sort of add a local controller scope to your Angular code. It's really cool. Previously, if you might click on a window, and this is like version 1.2, 1.3 of Angular. If you click on a window and there's a function called hide window, and it sort of percolates up the DOM and hits the wrong controller, then you're hiding the wrong window. So this new approach sort of takes this controller as and sort of resolves that issue. Thank God. All right, so this other approach, we're talking about prototype of all the things. The side effect of this, of course, is that no more factories, right? How are you going to make a prototypal version of a factory? A factory is a closure. It's difficult to do. Of course, the benefits of prototypal programming is that if you have a function, let's say 40 of those functions constructed, those objects constructed, and you have them in memory, you're only going to have one copy of those prototypal functions in memory at any given time. So it's a memory saver. It also saves time, honestly. I've converted a lot of code recently from sort of closure style into a prototypal style, and if any junior engineer comes in and looks at it, anybody that comes in and looks at it, it makes so much more sense, and it will honestly save you so much more time in Google searches for what the hell's going on, right? That's personal experience too. And honestly, in my opinion, it's the best way to code JS. So on the left side of this, you sort of see the same viewer factory. We call it a viewer service now because it's no longer a factory. And all those functions I had before, like the initialization, listeners, the animate render, they're all on the prototype. Not a problem anymore. But essentially, it allows us to have a far cleaner code structure than we had before. We're going to talk about prototype or Angular. So again, it's like on the bottom right, you sort of have this closure style. We use ng-annotate to sort of do the dependency injection. On the top left, we have sort of this prototypal style. We have the constructors with a dependency injected timeout and message bus. Notice that ng-inject annotation on the top there. We'll come up to that later. I assign sort of those dependency injected values onto the constructor, this statement, more or less. And then we have these prototypal functions, like init, for example, that sort of initializes the scene. Again, it's the same exact sort of approach as the factory function, but instead we're using a prototypal function to sort of extend the methods that we need. So annotations. I don't know if many of you are aware of Closure Compiler. I've used Grunt, Minify, and many other things. But Closure Compiler is a pretty cool Google project. it doesn't just minify, but it also does sort of type checking. It will rewrite your code. It does all these incredibly smart things that I would not know how to do unless I'm using this. Part of it is the annotations. So on the right side, you sort of see this translate function, right? So if I have an app param defined there, and I sort of compile this code, the Clojure compiler is going to inspect those annotations and say, are you in any place in your code calling translate and not using numbers for each one of the variables? If you are, it will give you a warning, error, it will bail out and not compile your code. And it's being like, you're going to break your application if you do it this way, right? So annotations are incredible. Additionally, this ng inject. So Clojure compiler, in a lot of Angular work, you have to use this weird bracket system to sort of keep your strings safe so it doesn't rename the Angular components you have. Clojure compiler, you can use this function called ng inject that essentially does that for you. So it makes your constructors far, far cleaner, I would say, as in demonstrated in the bottom left there. All right, so app initialization. Again, version 1, you essentially use your DOM to sort of bootstrap most of your controllers. So when the Angular system essentially digests your templates, it creates this initialization for these controllers. In version 1, sort of the initialization of all the controllers happens in your HTML. Right, version 2 takes us away from the HTML, and you sort of construct everything immediately within your app.js, your app initialization. And you can do everything. We're talking directives. These are these like polymer kind of things you can tag on the HTML. We're talking about filters, sort of like input ranges. So it's a great thing. An aside, input range sliders in HTML5 report back as strings, right? So you have an input range slider from 0 to 100 and you're dragging it, and you have some reaction to that drag, it's going to force it to be a string. So like I said earlier, if you pass a string into a Three.js position set, it's going to screw up everything and your model's going to disappear. So you can use filters to sort of circumvent that problem. Additionally, services and controllers. You can have, the code I'm working with right now, it's like you sort of have like a root controller that bootstraps everything. It's great. It sort of removes the requirements from Angular DOM HTML 1.3. Let me give that a second. All right, so minify and Clojure compilation. So there are two processes here. Version 1 uses ng annotate and grunt to sort of do this compilation. So the compilation is sort of like Uglify. Many of us are probably familiar with Uglify. ng annotate sort of takes care of that ng inject situation. It works great. Version 2, however, allows us to use Clojure compiler. We're talking about actually doing simple optimizations, looking at param annotations, doing everything else. Additionally, extern. So if we're using libraries like Angular, we're using libraries like Three.js, we don't want to rename those library functions because they're going to be called from internal system and they're going to include the libraries externally. So it's a really big problem. All right, so let's review what I've kind of talked about. We've got one app, 3D.js model viewer. We've got two patterns. If you go to the angularjs.org website, on the left side, like the code from version 1, that is what you're going to see. If you sort of search Stack Overflow or Google or anything else, that is what you're going to see. I can guarantee you that in the next 6 months, that's going to change. Version 2, prototypal for everything. We've thrown closures out the window. It doesn't really work with the prototypal approach. And from what I understand after talking with the Google types is that the 1.3 version, this controller as approach, is a bridge to Angular 2.0. So if you're producing a product and you're going to be forward thinking, it's like, where am I going to be in a year and a half or 2 years? You definitely want to use this controller as approach. Lastly, Clojure compilation. I mean, this is an incredible, incredible tool. If you are not doing that right now, I urge you to clone my code, understand what's happening, and start doing it. I was not doing it until this current position I'm in at a company, and it is amazing how well it works, how well it makes your code work in a production sort of environment. And this is personal, but I fucking hate closures. Anyway. All right, so lastly, I work for napabirth.com. if you want to take this kind of technology, this kind of WebGL technology and this Angular framework and create an incredible UI UX relationship to a 3D environment, this is what can happen, right? This is our product, screen capture. Can't really show much else. But again, if you go to our website with NG Meetup or WebGL Meetup or some hashtag, I don't really care, you can absolutely use it. What you actually see here is a map of music. It's sort of a map that shows the relationships between music as well. The layout of all the artists, Daft Punk is like prominent. Who doesn't love Daft Punk, right? It is the #1 prominence in electronic and house. I mean, it's incredible. Notice this little green line right here. This is what we call a subway line. Essentially what I've done is that after I started playing the Daft Punk video around the world in the top left, I clicked on the disco icon right there in the bottom right, and what you actually see is all the artists that relate to Daft Punk via disco tag. It's pretty awesome. So, that being said, we're looking for a few more people. Mobile developer, some back-end kind of super god guy, and some UI UX designers and QA. So if you guys know anybody who's interested, wants to work with a wonderful team, making a very, very cool product, let me know. That's what we got. Thank you.
Okay, everybody get that? There's going to be a quiz. That was a lot of information. We got time for questions. We got time to hang out, drink, and network some more. So let's start with you.
When you think of Angular, you normally think of a single-page application. So when you move from one page to the other, you are loading JavaScript essentially. I'm wondering if you've ever run into any problems leaving a Three.js scene, and how do you deal with garbage collection? How do you deal with removing the animation frame? And then do you ever go back to the scene and say, oh, we need to recreate all of this stuff? And does Angular facilitate that problem, or have you ever run anything like that?
So that's a good question. We're actually working on a single page application. Right now we have a bunch of different maps in this particular product that you have to translate between. If you structure your framework in such a way where there's limited garbage collection, that's not an issue. That being said, honestly, we're doing a page refresh between different maps because that is a large issue that I haven't figured out yet.
You're cheating.
We are. I like to think we're maximizing our profit margins or something like that. But that is like, if I could figure, that's on my long list of things to figure out. Yes, absolutely. I hope to do that soon.
Jamie, need Mike?
No, really quick. You said clone your code. Can you re-show
Yeah. I'm going to post this to the meetup page. The code's already live, so if you did grab that in the beginning. Again, Cubicle Downs on GitHub. Yeah, right there if anybody wants to Andrew. Yeah. I like this last picture though, it's prettiest.
Who else?
So, if you're going to use this code, use version 2. That's sort of the meat of this message.
Did you see the movie School of Rock?
Yeah.
Is Google maintaining the closure compiler still?
Yes, they are, and they're moving forward with that. Absolutely. I did this presentation last night in Mountain View, and they were all for it. Right? Closure compiler is used by just about every group inside Google. It is a wonderful product. If you're not using it, again, I encourage you to use it. All this code's up there. You should be able to clone it and just compile it immediately. It'll work.
Yeah, I +1 that I use it in my engine. Anybody else?
I got one more, actually.
Go.
Shoot.
So traditionally, when you rotate an object in a scene, you don't want to like drag a slider around. You want to,
Right.
click on it and get a gizmo. And Three.js provides you with orbit controls, like you mentioned,
Yep.
and like transform gizmo. But these aren't integrated at all with any data structure, right? Like you don't get the rotation of your object out of these things. Have you run into the problem of how do you get the camera position out of these controls and into Angular before?
Good question. So more or less you're asking whether or not an associated scene graph values with the scoped variables of Angular.
Sure, like maybe you want to serialize the camera position in
Right.
JSON and store it to the server. This doesn't come out of the box with orbit controls, for example.
Right. Well, yes, I have. But sort of this project, these two code bases, are demonstrating how to sort of bridge the gap between Angular and Three.js. Like part of, I've sort of laid the groundwork there to allow for exactly what you're talking about to happen with my select directive. But I wanted you guys as WebGL developers to be able to have some kind of framework just to pick up. It's well documented, that has the best processes, the best patterns to allow you to do this kind of work without much trouble, right? So you might have noticed at the beginning there was a number 4 there. I didn't mention that at all. I totally put it on the bullet list. That's exactly what you're talking about. And it's not done yet. So, all right. But it's awesome. I highly encourage everybody to go check out the code. Start, flag it, give me a pull request. And you notice I've typed something wrong. That's all I got.
Thank you so much, John. Big thanks to Eventbrite for hosting. Let's get a round of applause for them.